All right, think about this for a second. What if we could actually listen to our machines? And I don't just mean, the noise they make. I'm talking about the stories they tell. Today we're diving into how AI is basically becoming this super smart digital stethoscope for all our most important stuff, learning to hear the tiny signs of trouble way, way before disaster ever has a chance to strike.
Just imagine it, a bridge that could literally tell you it's in trouble, whispering its secrets long before you could ever see a crack. Or maybe a wind turbine that starts humming a specific warning tune before a single gear fails. And look, this isn't some far-off science fiction fantasy. No way. This is the reality being built as we speak, all thanks to this incredible mix of sound, vibration, and of course, artificial intelligence.
So the science behind all this has a cool name. It's called vibroacoustics. The absolute best way to get your head around it is to just think of it like a stethoscope, but for everything else in our world. Seriously, every single object, from a teeny tiny ball bearing to a gigantic concrete dam, is constantly producing its own unique symphony of sounds and vibrations. And hidden inside that symphony, well, that's its whole life story. Its health, how much stress it's under, all of its secrets.
Now, for decades, engineers have known that these signals held vital clues. But here's the thing, listening was never really the problem. Understanding was. This language that machines speak is just incredibly complex. It's a total mess of data, all buried in background noise. For a person, or even a normal computer program, trying to decode that in real time, it's like trying to hear one person whisper in the middle of a hurricane. Just impossible.
And that is exactly where AI enters the picture. So let's take a look at the first wave of this whole revolution, back when we first started teaching our AI stethoscope how to actually listen.
Okay, so the first real breakthrough happens between 2015 and 2019. This is using what we now call classical machine learning. Researchers started feeding all this vibration data into algorithms, stuff like support vector machines. And the results they got back were just stunning. All of a sudden, they could spot faults in these tiny little parts like bearings and gears with over 90% accuracy. The stethoscope was actually working. And of course, it wasn't long before they scaled it up to listen to entire bridges.
But there was a catch. These early AIs, they were fantastic assistants for sure, but they weren't the experts. A human engineer still had to basically spoon-feed them everything. It's a process called feature engineering, which really just means pointing to this ocean of data and saying, hey, listen for this specific sound right here and just ignore all the rest. It was a massive step forward, don't get me wrong, but it wasn't, true intelligence. But then, right around 2020, everything changed. The entire game shifted. We went from simply teaching AI to listen to teaching it to actively understand. The stethoscope was finally about to get a brain of its own. And you can literally see the shift happen right here. Take a look. Between 2015 and 2019, you've got about 23 major research papers on this topic. Okay, not bad. But in the 5 years after that, that number skyrockets to 73. That is more than a 300% increase. I mean, the field didn't just grow, it absolutely exploded.
So what on earth happened? What was the key that unlocked this massive surge in research and potential?
Well, the answer, in 2 words, is deep learning. And here's the fundamental difference, right? Where that classical AI needed a human to hold its hand and point out what was important, deep learning models could just go explore the data all by themselves. They could dive straight into that raw, messy signal and automatically figure out the hidden patterns, those tiny little fluctuations that really meant trouble was brewing. It was literally the difference between being the student and becoming the master.
And just like that, researchers had this incredibly powerful new toolkit. You had models like convolutional neural networks, or CNNs, that could essentially see the sound. They analyzed the vibration data almost like it's an image, spotting those telltale patterns. Then you had others like LSTMs, which could understand the story of the sound, recognizing how a problem develops over time. The AI wasn't just a helpful assistant anymore. It was quickly becoming the expert in the room.
Okay, this all sounds really cool in a research lab, but what does it actually mean for us, out here in the real world? Let's get into the real-world impact, because this is where this technology really, truly comes to life.
Hey, remember that bridge we talked about right at the start? Well, studies are now showing that deep learning models can analyze its tiniest vibrations and spot damage with close to 100% accuracy. Think about that. It's basically like giving the bridge its own nervous system, the ability to feel when something is wrong. Or how about our energy grid? A single gearbox failing inside a giant wind turbine can be completely catastrophic, not to mention insanely expensive. But now, AI models are listening in on those gearboxes 24/7.
detecting faults with over 95% accuracy. This means repairs can be scheduled long before a catastrophic failure even has a chance to happen.
And it's the exact same story in our factories. This technology is totally transforming them. By listening to critical pieces of equipment like compressors, AI can predict when they're going to fail. That prevents the kind of costly downtime that could shut down an entire production line for days.
So just how precise are we talking here? Well, this isn't some guess. In one study looking at air compressors, a model hit a diagnostic accuracy of 99.67%. Let that sink in. 99.67. That is the kind of near-perfect precision that takes this from being a cool science experiment to being an absolutely essential tool for safety and efficiency.
So where do we go from here? I mean, we've taught the stethoscope to listen, and now we've given it a brain to think. But what's it going to take to get this technology out there everywhere, working seamlessly and reliably? Well, that's the next frontier. Now, of course, it's not all smooth sailing. There are still some big hurdles. For one, the field needs standardized datasets so that researchers can actually compare models fairly, apples to apples. Another huge one is just getting enough data on actual failures. I mean, it's kind of hard when things are designed not to fail. And finally, these models have to be rock solid, not just in a quiet lab, but out in the noisy, messy, real world.
But the cool thing is, researchers are already tackling these challenges with some really brilliant solutions. To solve that not enough failure data problem, they're using something called unsupervised learning. That's where the AI just learns what normal sounds like, and then it flags anything that deviates from that baseline. Simple, right? They're also making knowledge portable with transfer learning. So a model that's trained to diagnose a car engine can take what it's learned and apply it to diagnosing a wind turbine. And with few-shot learning, they're getting to a point where they can train a super accurate model with just a handful of examples of a specific problem.
And all of this brings us to the ultimate goal, the big vision here. We're moving way beyond a future where this is just some add-on technology. The real aim is to weave these self-diagnosing systems directly into the very fabric of everything we build. Our bridges, our power plants, our cars, you name it. The idea is to create a world that is just fundamentally safer and more reliable from the ground up. Which kind of leaves us with one last really fascinating question to chew on. If we truly perfect this art of listening, if our machines can always tell us when they're about to break, could we one day build a world where things just never unexpectedly fail? It's a pretty powerful thought, and it's exactly the future that this technology is trying to listen for. Thanks for joining me.